Hello, my name is Manjuan, and I am starting to explain you about our IPNV file. So, first we import our all required modules. Now, our dataset have a large number of rows, so we are not able to get data frame directly using read JSON file. So, we require chunk size as 1 lakh and make our data frame. This is our data frame. Now, we show our data frame using info function. Now, we show our data frame using describe function. So, in machine learning model, we require to drop all non-null values. So, first we check in which column we have how many non-null values. So, we have review name and we have in review name column some non-null values. So, we drop them, and after that we have in review name column 0 non-null values. So, in machine learning model, we not require some columns. So, we drop them like ID, review name, review time, and assign. These are unnecessary columns. So, we drop them. So, this helpful column. So, I this helpful column is in second element is total number of users, and first element is how many users give positive response. So we make helpful yes column in which we have list first element, and helpful total column in which we have second element of list, and helpful ratio column. This is just divided. This is just helpful yes divided by helpful total, and then we not require our helpful yes and helpful total column. So we drop them. Now text and features. So in machine learning model, we require to know how many for detecting fake reviews. We require to know how many review word count and summary word count, because this is in string and we require numbers. So we just count the length. So we just count the word count of this review and summary. Now behavior features. Rating this overall column have ratings scale from 5 to is like 1 to 5. So we require to know how many columns, how many teachers have extreme rating 1 and 5. So we make this column, and in machine learning model we require to know how many users give positive response to this or home kitchen. So we require to user total reviews column. So we make them, and in this we require to know how many categories which we have. So we just concat our data frame with get dummies of this category column with prefix as cat. So as you can see on the screen, we have only one category as home and kitchen. So we not require that because all have same category. Now we saw how many features we have and how to relate with each other. So first we set our style. Now first we so how many fake reviews we have and how many genuine reviews we have. So first we make a bar chart which easily in which we easily show that genuine reviews is near 8 lakh and fake reviews is near 31 lakh. Now we require to know how many our features is correlated to with each other. So we show in this correlation heat map. So in this we easily show that overall and its extreme rating is highly related with class. So if we not drop them, then in our machine learning model this machine learning model is not proper because it is somewhere data leak. So we require to drop overall and its extreme rating column. Now we make review word count and summary word count column. Plot or scatter plot, in which we easily show that when summary word count length is small and review word count length is small, our our home and kitchen is high chance to fail. And in user total reviews and helpful ratio scatter plot, we easily show that when user total reviews, when more number of users give vote and helpful ratio is near 0.5 or 1, then we have high chance that this home and kitchen is fake. Then we make a box plot of review word count, in which we easily show that review word count of genuine reviews is high compared to fake reviews, and also average length of review word count in fake is low compared to genuine reviews. And after that we make helpful ratio and class KT plot, in which we easily show that when our helpful ratio is near to 0, then we have high chance to this home and kitchen is fake, and when helpful ratio is 1, we have high chance to this home and kitchen is proper genuine. So based on this graph, we require to drop some columns and then split our data. So we not require string columns. So we drop these string columns, and then we not require Unix review time because this is just a time in numbers, and also not category home kitchen because this is just because we have just one category. And as we see on our graph, overall and its extreme rating is highly correlated with class. So we also require to drop them. Then our target size is 3 lakh, and we require 20%, 20-80% ratio, and redemption 42. Now we saw in our first graph that we have data bias because fake reviews are more and genuine reviews are low. So we make somehow it balance. So we make data from balance using concatenation of two series, class 0 simple and class 1 simple. These both have fake reviews and genuine reviews rows. And after that we make x and y as data from balance, y as data from balance with class and x with non-class. And after that we split our data frame balance data frame in train and test part. So first we have 31 lakh fake and 8 lakh genuine rows, and after balancing we have near 19 lakh rows with fake and genuine. And in training data set we have 30 lakh rows, and in testing data set we have 75,000 rows. Now we just for training model we required to install XGBoost and some other modules which we required. Now we make evaluation model function. This is just a function for passing our model and our data, our predicting data and expected data for printing accuracy, precision, recall, and F1 score. So we make a function. In this accuracy, precision, recall, and F1 score is calculated, and after that printed. And after we make a dictionary named as matrices, and after that we print our classification report. So further part of random forest is explained by Ishan. Thank you.
All right. So, hello everyone. Myself Ishan Kaneria, and I'm going to explain further. Till now, we have understood that our data set is a binary classification problem. Either a review has to be a spam or a not spam. It cannot be both. So it's a classification problem. That's why you will see that we have two models. First one is random forest classifier and another is SGBoost classifier. And I'm going to explain both of them in detail. But first of all, let me give you a quick recap of what we have done so far. So as you see over here, this is our we have over 4 million entries. So out of the 4 million entries, more than 31 lakh entries are fake value or spam values, and only 8 lakh value are truly genuine reviews. Hence, if we try to train our model on the entire data set, then it will try to overfit on this imbalanced data. That's why we have used here. That's why we have we have distributed the data in 1,85,500 and 1,85,500 spam and non-spam values. That's why our model will not be biased towards a particular review or particular opinion like spam or not spam. So this is the main idea over here. And another feature is that we try to condense as many features as we can, because otherwise then the time will otherwise, because out of 4 million entries, if we try to train our model in the 4 million entries, then it will be practically time consuming. That's why we have only take you see over here, we have only take 3 lakh rows for training and 75,000 rows for testing out of what 31 million, or 3 million or 4 million entries. All right, so let's dive into the training model set part. We have first installed the SGBoost using the pip function. Then we have import the random forest classifier and SGB classifier. We have also import some important matrices in order to evaluate our model. And at last, we have import a joblib library in which we will able to save our model in a .pkl file. All right, this is a custom evaluable model which will give you a report card of a particular model. Now let's focus on the first model, which is a random forest classifier. We will initiate a variable rf underscore model and assign it with a function rcf and some parameters. Now what does an estimator does? An estimator means the number of decision trees. Here we have set at 150. So at max 150 decision trees will be used in this model. Now in a random forest classifier, we as the name suggests, forest. Forest means a collection of trees. Now a decision tree, one decision tree might not be useful, but if we have a collection of many decision trees, then we might get accurate answer based on the maximum number of votes we get from each tree. So the main logic behind random forest is that it will create 150 at max decision trees and will take the highest majority votes of all those trees and will output as yes or no. That is a review spam or not spam. Now max depth means the maximum depth or the height of the decision tree. So height means the length of the root node from the leaf node, like that. Class weight is to be balanced because we don't want to overfit on a particular review as a spam or not spam. We want an unbiased opinion. Random state, which means that we don't want a particular fixed state. We want some random seed to be formed. And jobs equals to -1. This will use all the CPU threads or something in order to evaluate the model faster by running them parallelly. All right. So now we will fit the training data set, and after that we will predict the testing data set. Now this line, as you see over here, is the most important because this is a classifier problem. And what a classifier problem does is that classifier is none other than a regressor problem, but here we will consider a probability above 0.45 50% to be true and less than 50% to be false. Now what does the predict proba means? A predict a probability of x means that whether a particular, it shows that how a model is confident towards its answer. A model can say that the particular review is spam or not spam, but this will tells us how much confident is to say whether a review is spam or not spam. As you see over here, it will it will store a 2D array of first not spam and spam. So this, as you see, this is 50% chance of a particular review to be spam and 50% chance that it's a non-spam. This is 26% chance or 26% confident whether a review is spam or not spam. A review is spam, and this is 74% chance that it is not spam, like that. So it's very important. We will only take the last element. That's why we will store such last entries. That means how much it is confident towards a spam value or a spam review. All right, now we will use our custom eval model function and print out the report card of the random forest. This is the report card, as you see over here. It says accuracy 62%, precision this and all that information. All right, now before that, let's move on to a confusion matrix, which is the most important, because based on a confusion matrix, all other matrices like accuracy, precision, recall, ROC score will be calculated. Now what does the matrix looks like? This is a true positive, this is false positive, this is false negative, and this is true negative. The diagonals has to be very large than these off diagonal entries, because this represents how well a model accurately answer a not spam review, and this value of true negative tells us how well a model accurately tells a spam review. And this tells us that how our model, so there are 15,000 reviews in which our model said that it is not it is spam, but it came out to be not spam. Similarly, our model tells that 12,000 entries are spam, but actually they are not. Sorry, no, 12,000 entries are said to be not spam, but actually they are spam. So this has to be off diagonal entries has to be minimum as possible, and this diagonal entry has to be maximum as possible. Now, based on this true positive, true negative, false positive, false negative, we will calculate the accuracy, recall, precision, F1, and ROC AUC score. Well, ROC, which will be, if you want to see more, you will find out that it is a receiver operating characteristic area under the curve. It's a very famous evaluation metric for the binary classification model like ours. So, all right, now let's move on to the second model, which is the SG boost model. Similarly, similar to the random forest, we will first initiate a variable SGB underscore model and set it to be the function name SGB classifier. And estimate is equal to 300. We want at max 300 trees. Max depth of the tree has to be 6. Learning rate has to be 0.1. Subsample point, and all of that are here described here. Now, one key difference between the SG boost and the random forest is that in random forest, it takes the maximum votes of the n independent decision trees. However, in SG boost, it goes on sequentially. Means it first create one decision tree, and then based on the and then create second decision tree and takes the good thing from the second decision tree and put it in the first decision tree, like that. So it tries to maintain what you say better accuracy than the random forest. However, the drawdown of the SG boost is that it is quite a time consuming because it goes sequentially, whereas in random forest it goes parallelly. But nonetheless, SG boost is generally a winner. All right, so we will feed the dataset training, and then we will predict the model, save it in the another variable, and then we will again what you say generate a report card of the SG boost model. This is everything, and again we will create a confusion matrix of the what you say this SG boost model. And now it's time to compare the random forest and the SG view based on the features. All right. So as you see, the random forest gives the highest weightage in the helpful ratio. Similarly, in SG boost, the highest weightage of a particular feature is given to the helpful ratio, but the percentage assigned to the helpful ratio is 40% in random forest, whereas in SG boost the helpful ratio is given more than 50% of the weightage. Similarly, we will check that a particular feature has what number of weightage over there. Now now we have to compare both the models and have to save the best model. We create a data frame containing the what you say the evaluating matrices, and now based on the F1 score, let's classify the best model. Now, as you see over here, 0.693 is of the random forest and 0.64 is of the SG boost. Hence, the SG boost is the winner, and we will save the SG boost model as the model.pkl. And when you see over the home page, you will scroll down and you will see that there is a model.pkl file over here, which is our SG boost model file. All right. So this is it. And for further hardness, we could also manually, instead of manually assigning these values, we can also fine tune using certain boosting algorithm like gradient boosting and whatever. But we don't want to get that further hard, and that's why this is what we have created using the original Kaggle dataset of the Amazon reviews of the home and kitchen appliances. All right. Thank you.